All right, so topic 4, we're going to determine slope from a verbal description. So basically, we're given like a scenario, and we have to use that scenario to help us find the slope of the relationship. So the easiest way to go about that is probably to use one of these 3 methods. Okay, we are going to take the situation and either create a sample table of like some possible numbers that would work in that scenario. We could create a graph of the situation, or we can write an equation that represents the situation. So our example up top says Alyssa wants to make sure that she orders enough pizza for all her friends who come to her birthday party. She expects each friend to eat 3 slices of pizza. What is the slope in this proportional relationship? So starting with making our table, okay? Our input is our X value. Our output is our Y value. Your input is going to be your independent variable. So you can squeeze that kind of along the side here. And if you think to science class, your independent variables is what is going to be placed along the x-axis. So for instance, usually time is an independent variable, so that is normally along your x-axis. Your y-axis, your output, is going to be made up of your dependent variable. So in this case, we're talking about how much pizza Alyssa needs to get, and about how many friends are going to come to her party, okay? So between those, we're trying to figure out which is independent and which is dependent. It would make sense that the number of friends or the number of people that are able to come to her party would have an effect on the amount of pizza that she decides to order. So the number of people is your input or your independent variable. The amount of pizza is your output or your dependent variable. Now, she expects each friend to eat 3 slices of pizza. So let's come up with some possible values here. If, for instance, the weekend of her party, maybe it was a holiday weekend, maybe people had a lot of different like sports tournaments they had to go out of town for, and there's only one person that's able to come to her party, okay? Well, we know she wants each friend to have 3 slices of pizza, so that would mean she would need to have 3 slices of pizza for that one person. Let's say things were a little bit better and she could have like 5 of her close friends come to her party, okay? Well, how many slices of pizza would she need? 5 friends? 3 slices for each person? She would need 15 slices of pizza. And if it was a great turnout, 10 people were able to show up, she would need to have 30 slices of pizza. So a lot of you were probably able to kind of come up with these numbers in your head, but what is happening here is because she needs to have 3 slices for each friend, okay, each right here is telling you an operation, and that operation that's happening is multiplication. So 1 person times 3 slices of pizza gives you 3 slices of pizza. 5 people times 3 slices of pizza gives you 15 slices. 10 people times 3 slices gives you 30 slices, okay? So what we're doing here is we're trying to figure out what our slope is of this table. So if you're able to see or recognize, hey, I'm multiplying by 3 each time, then you can recognize that's what your slope is. If you were dealing with numbers that were not so obvious, remember you can always work backwards. And you can do y divided by x to determine your slope. So in this case, you would have had 3 divided by 1. You would have had 15 divided by 5. And then you would have had 30 divided by 10. And of course, each of those, when you divided them out, would have equaled 3. So that is consistent with what we got when we were multiplying, right? So our slope would be equal to 3 because that's what you're multiplying by. Now, since we really haven't done anything with graphing yet, on our coordinate plane or graphing our slope, we're really just going to use our table to help us plot some possible points over here. So if you look at your table, okay, these are your coordinates, okay? So I have the point 1, 3. I have the point 5, 15. I have the point 10, 30, okay? When I look at my table or my graph over to the side, my grid over here, my input or my x-axis would be my people, so I'm going to label that people or number of friends. And again, my output or my y value, my y-axis, is the amount of pizza that needs to be ordered. So if I plot the point 1, 3, okay, just as a reminder how we plot points, okay, we'll write this up towards the top of our page here. So if I have, when I'm plotting a point, I have my x coordinate, and that tells us how far we're going left or right. If we're going to the left, it's represented by a negative number. If we're going to the right, it's represented by a positive number. And then we have our y coordinate. Our y coordinate tells us how far up or down we go. If we're going up, it's positive. If we're going down, it's negative, okay? So our first point here, 1, 3, that would mean I start at my origin and I would go to the right 1 and up 3. Start at the origin, go to the right 1 and up 3. That's my first point. Now I do kind of run into an issue here, and that's that my number lines, my axes only go to 6. So I can't plot the point 5, 15. I could go to the right 5, but I would be off the graph with 15. Same issue with 10 and 30. So let's come up with like another possible number that we didn't have in our table, but one that would fit on this graph. So for instance, let's say even Alyssa herself got sick. She came down with the flu and she can't even go to her own party, okay? So 0 people come to this party. She would need 0 slices of pizza. So that could give us a second point now that we could plot. We could put a point at 0, 0 at the origin. Alternatively, maybe you might have thought somewhere in between the 1 and the 5 people, maybe if 2 people came, then she would need 6 slices of pizza. That's another point that we could have come up with as well. But you just need 2 points in order to create a line, okay? So now I can connect these points, and you just need some sort of a straight edge. It can be a ruler, it can be the side of a notebook, side of a sheet of paper, side of a Post-it note like I have here, okay? You just connect the points. If I have my graph done, then I could use my rise over run in order to calculate what my slope would be. So rise over run. Rise is how far up or down we go between our points. So for instance, if I start at this one in the middle here and I go up to that second point, we're looking at how many lines I had to go up. And I went up 3, so that would be represented by positive 3. So I have a positive 3 for my rise, and then you have to go over 1 line, so that's represented by a positive 1. So my run is a positive 1. Again, when I have positive numbers, I don't have to write the plus sign in front of them. So this is the same as 3 over 1. And of course, if I simplify that, 3 divided by 1 is 3. So using a graph, I could still arrive at the conclusion that my slope is 3. Now, being that we haven't done anything with our graphs yet, this is probably just more work at this point because you're having to start with a table first anyways. But as we get more comfortable with graphing, that might be an option you choose. And then our third method here is that we could write an equation for the situation. So again, situation is She's inviting friends over for her party. She expects each friend to eat 3 slices of pizza. Here's my equation form that I use. Y equals mx plus b. If I'm looking for the slope, I'm looking at what value would be in the spot where the m is. Which number gets multiplied by each x value? Well, if I look up top in my table here, or if I just think about the scenario, if I haven't done the table yet, okay, my number of slices that I need total, or that she needs total, that's going to be equal to 3 times the number of friends that can come. And then, does she need any leftover slices? Does it talk about giving any extras to like her neighbor or to her dog or anything like that? No, there's no mention of needing extra slices. So we can just say plus 0 extra slices. If I take what's in words here and then now write that as my equation, my number of slices, or y value, is equal to 3 times my x value, which is my number of friends, plus 0. And because I'm looking at the m here in my equation, m would be equal to 3 in this case, because the 3 is where the m is in the equation, and that means that my slope is 3. So we can conclude that whichever method we use to interpret the verbal description or the word problem, whether you decide to create a table with possible values, draw a graph, or write an equation, for all of those methods, we could discover that the slope is equal to 3. Now, some of these questions that follow, we're kind of looking to go an extra step. Okay, so we're going to use the information that we just figured out, actually with our equation up top, to answer some of these questions down below. So if Alyssa plans to have 14 people at her party, and we will say, just to keep it simple so there's no confusion, we'll say that is including herself. Okay, so 14 people total. Then how many slices of pizza does she need to have available? Okay, so we're going to use that equation that we had up top there. So we have y equals, well, our format is y equals mx plus b. Up top, we substituted in 3 for m. And in this case, if we say that there's 14 people that she expects to come, that's our x value. So we can substitute 14 for x, and then again, with our equation up top here, we said we did not need any extra slices. So basically, plus 0, adding 0 doesn't change anything. So essentially what we're doing here is we're just multiplying the 3 times the 14. And if I multiply 3 times 14, that would give me 42. So how many slices of pizza does she need to have available? She needs to have 42 slices available. We're going to use what we just calculated in this question to answer the second one. So now if each pizza, let's say, has 8 slices, which is pretty normal. Okay, some smaller pizzas might have 6 slices, some extra large pizzas might have 10, but 8 is pretty normal. So we'll say each pizza has 8 slices. How many pizzas will she have to order? That's what we're figuring out here, okay? So how am I going to figure out how many pizzas she has to order? You take the 42 slices that she needs, you divide it by the 8 slices in a pizza, and when you put that into your calculator, it's going to give you 5.25. Now, last I knew, you could not call up Domino's and order a quarter of a pizza, okay? So we're going to have a whole number for our answer here. Usually with rounding, we would round down to 5, right? Because this 0.25, that's a quarter, that's less than a half. However, if she only orders 5 pizzas, there's going to be a couple of friends that kind of get gypped there. They only have 2 slices instead of 3. That's not fair, right? So in this case, even though the normal thing to do would be to round down, we're actually going to round up to 6. We will have some extra slices. That's okay. We didn't need them, but that's the only way to be able to give all 14 people 3 slices apiece. So how many pizzas will she have to order? She will need to order 6 pizzas.